13.5, solving trigonometric equations. So what we're going to do here is we're going to solve trig equations, and to do that, the main thing I know is your unit circle. So I have the table set up right there. I'm going to use triangles. We have to need a unit circle. And what we're going to do is we're going to solve trig equations. So let's talk about the process of doing this. So 1, solve like normal. So what do I mean by that? I mean if you have one trig function, just trig, just solve. If you have more than one trig function, what we do there is we factor, set equal to 0 and factor. Step 2, use all students take calculus. To find the quadrants we're going to use. And 3, either use triangles or table to find the angle. To find angles, which is the answer. So that's the process. 1, we're going to solve like normal. So if you have one function, just solve for it. If you have more than one, like I have here, I have 2. I got a factor set equal to 0. Or set equal to 0 factor. Then we're going to use all students take calculus to find what quadrants we want to talk about. And then once we do, you triangle to the table to find the actual answer. So let's start here. So look at this one. There's more than one trig function, so I got a set equal to 0. Look, that's already done. Now I got a factor. But look at what they have in common. They have a cosine in common. So I can factor it out. So like cosine theta, sine theta, minus 1/2 equals 0. Then we're going to solve this like normal. We split and solve. So cosine theta equals 0, and sine theta minus 1/2 equals 0. So now I got to solve this side. Try to get sine by itself. Sine theta equals 1/2. Now let's solve this one first. So step 2, since I solved like normal. Step 1, step 2, use all students take calculus to find the quadrant we're talking about. So I'm going to go like this. All students take calculus. I'm trying to figure out what quadrant is my answer going to be in. Now sine is equal to, I'm doing sine right now, so all students take calculus, right? Only A and S is positive when you're doing sine. Other two are negative. My value here is positive, so I should be in quadrant 1 or quadrant 2. Next step, let's find the angle. Now I'll do the table first, right? So my sine equals 1/2. So look at the table right here. So sine, why is it so off? There we go. Sine, where does sine equal 1/2 at? 30 degrees, right there. So I know this has to be 30 degrees and 30 degrees. So if I find this angle in degrees, like it asked me to, it's going to be 30 degrees up. And remember the way to find the spot right here. This is 180, and you're 30 degrees back. You haven't reached it yet. You're off by 30, so 150. Those are my two answers for sine theta equals 1/2. I still got to solve this one. Where does cosine equals 0 at? Well, look at your table right there. Cosine equals 0 at 90. So according to the table, it's at 90. Now it's a little tricky because it should equal 0 at 2 spots. If it equals at 90, it should also equal at 270. But why isn't that an answer? Because it only wants from 0 to 180. So actually, I don't care about this. I just care about this, this, and this. And that's the process, right? So if there's more than one, you have to factor it, split it, solve each one separately. Sine theta equals 1/2. How do I figure out where that happens at? All students take calculus. Okay, we're doing sine, and it's positive, quadrant 1 and 2. Then you either use a table, 1/2 right here says 30, so 30, 30. Or you use SOHCAHTOA. In that case, it would have been like opposite is 1, hypotenuse is 2. You have to know that's a 30-degree triangle. And that's kind of the idea. Let's do more. Now this one, let me change this. Oh crap. Let me change this a bit. Let's do a more basic one before we do that one. Let's use 2 cosine theta plus rad 3 equals 0. So let's solve this. Now notice how there's only one trig function this time, so I'm just going to solve for cosine. It's a more basic one. Don't have the factor, don't do any of that. Just solve for cosine. So let's subtract rad 3 from both sides. I get 2 cosine theta equals negative rad 3 divided by 2. So cosine theta equals negative rad 3 over 2. So remember, I got to solve this. So first step, next step, all students take calculus. In this case, we're doing cosine. Right? I have a cosine graph. Cosine is positive at C and at A, because A is always in C stands for cosine, so it must be negative at these two. Now look at my graph. Look at what. So next positive here, negative there. I have a negative value, so I'm going to be in the negative ones. Quadrant 3 and quadrant 2 and quadrant 3. Now again, how do you get the angle? That's what we need to find out next. Two ways. You can do the table where you go, okay, here's my table. My cosine is negative rad 3 over 2, so we'll go for rad 3 over 2 right there. Go to 30. So these are 30 degrees. That's way one. That's using the table. If you can use using triangles, you go SOHCAHTOA. This is rad 3 over 2. Rad 3, this is 2. Rad 3, 2. That makes this side has to be 1, which makes the angle 30. So again, that's how you're doing if you're using triangles. If you're doing the table, you just go to the table, go backwards. You figure out the angle. 30. Okay, so now I gotta find our answer. So remember the way this starts off, you start here at 0. That's supposed to be a straight line. And you go to 180. You're 30 short, so 150. And you're 30 more than 180, so 210. And then what will you be done? Except for the fact they wanted radians. So yes, you can convert if you want. That's the baby way. The easiest way to do this in radians is, let me rewrite it because it'll make it a little easier. The easiest way to do it in radians is this. 30 degrees, the same thing as pi over 6. So we make this 6 over 6. One less is 5 pi over 6. And one more. And that's how you do in radians. Same idea, 30 degrees is the same thing as pi over 3. So 6 over 6, one less, one more. Pi over 6, as I say. Let's do another one real quick. Solve 2 sine theta for x equals -1 for all values of theta measured in k. So for this, they want infinite main solutions. What you do is this. You solve like normal, but then add plus 2 pi k. Because remember, the period of sine is 2 pi. So you just keep on going around in circles, quotient angles over and over again. So that's all that is. So let's do it. So let's solve for sine, right? Divide by 2. Sine theta equals -1/2. So I gotta figure out what sine equals -1/2 at. All students take calculus. Sine is positive at A and S because A is for all and S is for sine, and negative down here. This answer is negative, so draw our triangles in the negative portion. So again, I don't care how you do this. So SOHCAHTOA, opposite's -1, how much is 2? You figure out it's 30, or look at the table, 30. Either way, you get this is 30. So again, then how do we answer this? You can do it in degrees range. We'll do it in degrees this time. You start here, always at 0. This is 180. I gotta go all the way around, so I'm plus 30. So 210. I'm gonna do the same thing for this one, right? All the way around to here. This is 0 and 360. But you're 30 away. So 330. If we're just in radians, it's kind of like we did last time. Be pi. Right here be pi, 6 over 6, because it's 30. One more, one less. Over there, 12 pi, one more, one less. So that'll be the idea. Now, I wanted infinitely many solutions, so my answer actually should be this. 210 plus 2 pi k. And what that does is it makes you go around in a full circle to hit 2 pi 10, 210 again. Just keep on going around. So that's that one, and then we also do the same thing with 230. Plus 2 pi k. So yeah, this means you go around a full circle next time you want to hit it. Next step, let's go deeper in this. Now this next part is about how about extraneous solutions. So what's gonna happen here is some of the answers not gonna work. Keep in mind so how does this happen? When sine and cosine are more than 1 or -1. Those two going to be between 1 and -1. Unit circle. Right? Think of graph of sine and cosine. Max is 1, -1. So if anything for sine and cosine, if you do anything bigger than 1 and -1, it's not going to work. It's no solution. So now we understand that sine and cosine has to be between -1 and 1. So anything bigger than that to be undefined or no solution. We have to solve this. Now, see this problem here? Notice how it's in a factored form. It's in quadratic form. So the factor. So a lot of times what I do, I just ignore the sign. So it's 2x squared minus 3x minus 2. Then factor it. So then multiply these. There's a number of us, so we multiply those together. -4x squared. Two things that multiply, you get 4, but add to get -3. So -4x and 1x. Plug it in for the middle. So 2x squared minus 4x plus 1x minus 2. Factor by grouping. These have a 2x in common. X minus 1. These have nothing in common, so you put a 1 on the outside. X minus 1. 2. 2. For both of these. There we go. Sorry about that. Factor that. X minus 2. 2x plus 1. Right, so now it's factored. So now I can plug the signs back in. It's going to be sine x minus 2 and 2 sine x. There we go. Not too ugly. Equals 0. Right, so again, all I did was factor that. How do I factor it? I just ignore the signs, make them like x's. Factor like normal, then plug your signs back in. So now we're going to solve this. We're going to split and solve. Sine x minus 2 equals 0. 2 sine x plus 1 equals 0. So I get sine x equals 2. And then if I was solving this one, subtract 1 divided by 2. Sine x equals -1/2. So sine x of 2 you cannot solve. It's too big. You can try to, it's not going to happen. Right? Sine has between 1 and -1. The sake of a sine graph. Think the fact we're doing a unit circle. Right? So you can't solve it, no solution. This one we can solve. We've been doing it all day today. All students take calculus. Notice how it's negative. Sine is positive A and S. This is a negative, so it's between T and C. And then you can either make triangles and go opposites -1 and 2, or you could look at your graph, your table, and make it 1/2, so it's 30. So again, the way we're gonna do that, this is 180. If you want to know what 30 is, it's 30 past 180, right? We're going this way, 180, and we're going to go extra 30. So 210. For doing this one, all the way around would be 360. But we're 30 away, so 330. Those two are the answers. Now, if we look back at the top, again, they wanted radians. So how to do that? Same concept. This is 30, so that's pi over 6. So you put this pi over 6 over 6. One more would be 7 pi over 6. If you wanted this one, if you double, you get 12 pi over 6. One less will be 11 pi over 6. So that's it in degrees, and that's it in radians. Same thing. Let's move on to the next one. This next one's going to be tricky. So this one, if you notice, you have sine and cosine equals 4. So there's no way I'm going to be able to solve it. It's like set equal to 0 and factor because it's not going to work so well. We actually have to use the formulas. You see sine squared here? We're going to change that to 1 minus cosine squared plus 2 cosine squared, just rewriting this part, equals 4. Now if you look at it, I could add the cosines together. And I'm going to get 1 plus cosine squared. Theta equals 4. And then I'm going to subtract 1. I get cosine squared theta equals 3. And then let's square root it to get rid of the square. I get cosine theta equals radical 30. Now, but rad 3, if you're not sure, is like 1.54. That is bigger than 1, so no solution at all. Okay, let's move on to some other ones. Now, this one, next one's where it gets even harder. Now they want you to use trig identities, so we're combining the last few lessons here. So to solve this, first I want to do the trig identity. It's like here, right? Remember the rule is, if you're not sure, the trick is switch anything that's not sine and cosine. So this is going to be sine theta. Cotan is cosine over sine. Minus cosine squared. Now here, the sines cancel. I'm left with just cosine theta minus cosine squared theta. Now remember the way we solved theta equals 0 is you factor it. These both have a cosine. And now you could split it and solve. Cosine theta equals 0. We'll talk about that in a second. And 1 minus cosine theta equals 0. Add cosine both sides, 1 equals cosine. So 2 ways to solve this. Right now that we have cosine theta and cosine equals 1, you could use your table here. If you notice, cosine equals 1 at 0. So cosine equals 1 at 0, right here using the table. And now where does cosine equals 0 at? So in this case, look at cosine, where does it equal 0? Right here at 90. So I was doing this one, it happens at 90. But it also happens, also known as pi over 2, at the opposite side. Negative, so which would be negative 0, which is still 0. So it happens at 270. Or 3 pi over 2. Right, so again, given a formula, you have to do, in this case, you have to do my little simplification. Then you could factor what they have in common, and then you can split and solve each one separately. And that's the key to this problem, split and solving each one separately. So a couple more just to practice some of our stuff. This one, right, if you remember, this one, my favorite trick is to move this thing to the top. So if it's a cotan on the bottom, it becomes a tan on top. So let's just rewrite it. I got 10 cotan plus 2 sine squared equals 0. Cosine, sorry about that. Tan is sine over cosine. And we already have a cosine. These cancel, I just get sine plus 2 sine theta equals 0. And we're going to solve very similar to the last one. Factor what they have in common, they both have a sine. You have 1 plus 2 sine equals 0. We're going to split each one. Sine theta equals 0. 1 plus 2 sine theta equals 0. Solve for theta, sine. Subtract the 1. And I get sine 2 sine theta equals negative 1. Divide by 2. Sine theta equals negative 1 over 2. Remember, you're not done with these two. You still got to find where does that happen at. So sine of 0 is what we talked about earlier. Where does sine equals 0 at? It happens at 0. But it also happens on the opposite side at 180. Where does sine equal negative 1/2? That one's a little trickier. You have to do all students take calculus. Sine, this is a negative value. Sine is positive at a and s, so it must be negative down here. Now it's your choice. You can either do triangles or you can use a table, right? So in this case, I'll do a table because we have it right here. Negative 1/2, where does sine equal 1/2? 30 degrees. So it's 30. And again, we need the angle from here. Very important, angle from there. So that's 0. If I go all the way to here, it's 180. Plus another 30. So I get 210. If I'm trying to get all the way down to here, it's 360. But I'm 30 short. So 330. And that's that one. Next. So now this one's, how do we solve it when there's something inside like this? Parenthesis. Well, all the key is to ignore it till the end. So you just want to solve this like we normally do. So we're going to do all students take calculus. right? Sine is positive at A and S. This is a negative again, so we're going to be down here and here. But look at the thing they gave me, rad 3 over 2. So again, if you want to do the table, we're doing sine rad 3 over 2 is 60 degrees. Or again, if you want, you can draw a triangle, blah, blah. Sine is opposite of hypotenuse, so it's like this. And then you gotta find the missing side. So a squared, b squared, c squared. It doesn't even matter. You have rad 3 right there. Opposite of rad 3 is 60. That's what I meant to say. Ha. So you know, oh, if I have rad 3, it's going to open to a 60 degree angle. And like last time, find the angle. You're trying to go to here. This is 0. You gotta go all the way to 180 plus an extra 30. 60, sorry. Because of the angle. So you get 240. If I was doing this one, all the way around to this line, that's 330, that 320, sorry. 300. And then you're like, wait, because you're 60 apart, that's why it's 300. Right, because that's 60, this is 360 minus 300 or whatever I had. So you get that. Now I'm not done, because if you notice, I didn't use a 2. Now that's where we're going to use this. So how does that work? Well, the answers you got, this said equal to 2 theta. 2 theta equals 240. And 2 theta equals 300. Divide by 2. Theta equals 120. Divide by 2. Theta equals 150. We'll do a few more. So this next one. Right, so I just got to solve it. If you notice, they both have a sign, so you're going to factor it out. End up with sine minus 1 equals 0. Same idea, we'll split it. Sine equals 0. Sine minus 1 equals 0. So you get sine equals 1. Again, a couple ways to do this. Table, where does sine equal 0? 0. Where does sine equal 1? 90. Don't forget this also has to be 180. If you're doing a triangle method, you gotta keep in mind where does sine equal 0 and 1 at? It's one of these points here. It's always be one of those points. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. If I was doing, so to have that, that's how you do it by triangles. So you have your answers. Right, where does sine equal 0? Sine E, right here and right here, 0, 180. Where does sine equal 1? Sine E, where's 1 at? Right there at 90. That's the idea. Again, a couple more. 2 cosine squared theta equals 1. So again, notice there's only one trig function, so we're going to try to solve for it. Let's divide by 2 first. Cosine squared theta equals 1/2. Now you might be thinking, how to get rid of the square? Well, we square root it. Cosine theta equals square root 1/2. Now here's a tricky thing. Remember, you can separate it. Cosine square root of 1 is 1. Square root of rad 2 you can't. So I get this. And don't forget, square root is plus and minus. So actually here, cosine can be plus rad 1/2, minus 1 rad 2. Either way works. So we're doing that table. All students take calculus. I'm going to use the whole table. So it could be there, it could be there, it could be there, it could be there. Because it's plus and minus. Now it's 1/2, 1 over rad 2, sorry. So let's write down one of our formulas. So or you can look at the table, but it's rationalized. Opposite, hypotenuse 1, opposite rad 2. That's a 45, 45, 90 triangle. So these are all 45. So again, you can either figure out each angle. That's 45. This is 180 minus 45, 135. 180 plus 45, 225. And then 360 minus 45, which is 335. You can also need radians. It's pi over 4. So it'll be 1 less 3, 1 more 5, 8, and that would be 7 and 1, or 9. Okay, let's do the last couple ones. This one, half angle, skip that one. This one, double angle. How about this one? So again, notice how I have sine and cosine. I don't want to have two different ones. So what I'm going to do is I'm going to switch this sine to theta. If you remember the formulas I do give you, that is a double angle formula. It was on the last lesson. So we're going to switch this to 2 sine theta cosine theta minus cosine theta. Now we're going to solve like normal, right? So it's more than one function. So we say it equals 0. We factor. These both have a cosine. You're left with 2 sine theta minus 1. Again, all I do is factor it out. So remember, if there's more than one trig function, say equal to 0, and then factor. And then we split. Cosine theta equals 0. 2 sine theta minus 1 equals 0. Solve this one. 2 sine theta equals 1. Add 1. Divide by 2. Sine theta equals 1/2. Now again, I don't care how you solve this. Any way you want to do it's fine. Where does sine theta go 1/2 at? Let's do all students take calculus. Notice this is positive. So I'm going to be at A for positive, right? All. And then I'm going to be at S because we're talking about sine. If it was negative, it would be down here. So then how do you figure out what angle it is? Well, if you're doing triangles, it's opposite over hypotenuse. And you got to know what triangle that is. That's 30. If you're doing the table here, where does sine equal 1/2? At 30. So 30 and 30. So my answers are 30. And again, I'm trying to get to here. This is 180, and you're 30 short. So 150. If you're doing in radians, 30, you gotta know 30 is pi over 6. So how do I do this? Well, it's going to be 6 over 6. 1 less, 5 pi over 6. That's how you do in radians. Okay, so when does cosine equal 0? Doing the table way, you gotta remember, oh, 0, 1, that's one of these things. So where does cosine equal 0 at? Well, this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosine's the x value because sine's the y value, sine e. So we're looking at these two. So 90 and 270. Also known as pi over 2 and 3 pi over 2. Next one. So another one knows how it's like a trinomial. So this one we're going to factor. It's a little simpler. What two things multiply you get 1, but add you get 2? Just 1. This is like factoring. Let's say it's like factoring x squared plus 2x plus 1. You just get x plus 1, x plus 1. Also known as x plus 1 squared. So if I wanted to solve this one, I'll just do 10 plus 1, 10 theta plus 1. Just like I factored it. Equals 0. Split it, they're the same one, just we gotta solve one of them. 10 theta plus 1 equals 0. 10 theta equals negative 1. So again, how do we solve that? All students take calculus. 10 is positive at A and at T because T is 10%. These two are negative. We have a negative value, so let's draw our triangles in the negative quadrants. And again, it's all about which one you're more comfortable with. If I'm doing triangles, I'll make this negative 1 over 1. So negative 1 over 1. Same thing. And by that, I should know that's a 45-degree angle because it's 1, 1, rad 2. If you're not doing that, look at your table. Here's 10, 1. So it's to be 45 degrees. 1 is at 45 degrees. So my answer is going to be from 0, this is 180, right? I'm 45 short, so 135. And the same idea here. I go all the way to 360, but I'm 45 short, so 315. That's how you go backwards. Last one, and we'll stop. So this one, cosine 8 theta equals 1. Remember, don't overthink it. What you do here is you just do this and ignore it till the end. Just solve cosine w equals 1 or something. So where does cosine equal 1 at? have it at 0 and 2 pi, pi over 2, pi, and 3 pi over 2. And again, this keeps on going on forever and ever and ever. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now again, we're doing cosine, and cosine's the x value, sine equals sine y value. So we're actually doing, where does cosine equal 1 at? That only happens here. So at 0 degrees and at 2 pi degrees. So let's rewrite it. My answers are, right, I ignore now, I'm not going to do it, is 0 and 2 pi, or 0 and 360. And then you got to solve the problem for A. Divide by 8. A equals 0 and pi over 4. And that's it.